This is a T cell. A T cell is a white blood cell that lives in our body. This guy is part of our immune system. He fights viruses and keeps us from getting sick. We have lots of them. In MS, some T cells tend to go a little crazy and start causing more harm than good. These autoreactive cells start attacking our brain and spinal cord. No one really knows why this happens. The trigger may be in our genes, a virus, or even something else in our environment. With a few little tricks, T cells can wiggle out of our bloodstream and get into our brain and spinal cord, where they can cause major trouble. T cells use adhesion molecules to anchor down near the blood vessel wall. T cells have a special hookup called VLA4 that locks in with the adhesion molecules. Once anchored, they sneak through the blood vessel walls by secreting matrix metalloproteinases. In our brain and spine, nerve cells are everywhere, and we use them for almost everything. Walking the dog, eating dinner, playing soccer. We constantly use our nerve cells to send signals from our brain to our body. This is the myelin sheath. Myelin wraps around the nerve cells, neurons, to allow messages to travel to and from your brain super fast. That's important when some nerve cells are several feet long. Once the autoreactive T cell recognizes that myelin is near, all havoc breaks loose. The T cell releases cytokines, which is like the bat signal for bad guys. T cells' henchmen all show up, macrophages and B cells. The B cells transform into plasma cells and release antibodies that attack the myelin. Macrophages dump nitrous oxide chemicals onto the myelin, causing further injury. The longer this beatdown goes on, the more difficult it is for our nerve cells to carry our signals. Kicking the soccer ball becomes more difficult. We become exhausted. This is an MS attack. In the worst cases, this myelin-munching crew will chew this thing all the way to the nerve itself, breaking its ability to send signals. To keep that from happening, we need to repair that myelin coating before the bad T cells come back. Our body does this with oligodendrocyte. This cell, Ollie, will wrap arms and legs around and around the nerve cells to make new myelin. T cell and his sidekicks can cause major damage in just days, but Ollie needs more time to repair the myelin. That's why recovery from an attack or relapse can sometimes take weeks to months. Ollie lays new myelin on so thick those electrical signals pass through the nerves like greased lightning. Let's explore the treatment options to learn how they keep the evil T cell and his buddies under control. Copaxone is made up of 4 amino acids, the building blocks of protein. Similarities exist between the amino acid sequence of Copaxone and that of naturally occurring myelin. Copaxone injected under the skin can cause an increase in immune cells that can lessen the immune attack. These T cells are called Th2 and T regulatory cells. These cells can travel into the brain where they can help protect myelin. Interferons are proteins our bodies naturally make to fight viruses. If a T cell becomes too hyper, it can divide. Outside the brain, interferon prevents T cells from becoming too riled up and splitting into more misfit cells. These T cells are on a tight leash. Interferon keeps T cells out of the brain by blocking them at the blood vessel wall. Everything in the T cell's dirty bag of tricks gets blocked by interferon. Interferon even causes some of the autoreactive cells to die. Tysabri is an antibody therapy given in the vein. Tysabri hunts for T cells swimming in blood vessels. There is a landing pad for Tysabri on the T cell called VLA4. Tysabri prevents the autoreactive T cell from docking onto the adhesion molecule on the surface of the blood vessel wall. The evil T cell can't cross the blood vessel wall and never gets into the brain and spinal cord.
To learn more, visit www.mslivingwell.org.